Hello everyone, welcome to my channel. Today we're gonna be revisiting a previous model that I created ages ago. And if you have been following the channel or you're subscribed, you'll know that probably this was one of the first videos that I uploaded is to how to design a truss with STAAD. Today what I'm gonna do is to show you how you can automate the design with STAAD. I'm saying it this way because um, I'm always a little bit, don't know, unsure if you leave STAAD to do the design, if what you're gonna get is something correct. It should because this program has been there for ages, so shouldn't be a problem. Or someone should have already highlighted that the design doesn't work if you automate it. So today in this video, what I'm going to show you is what are the results obtained by just using the automate stat design, and what would you obtain if you do the calcs by hand. So following the Eurocode, putting the formulas. Of course, when I say by hand, I don't mean that you're gonna take a piece of paper and start doing things. Just I have MATCAD calculation sheet that helps me to this kind of checks at my work. So I trust in that spreadsheet, and let's see how it works. So from the previous video, if you haven't watched it, I recommend you to do so to see how I create this structure. If you're already familiar with that, then you won't have any issue by or while creating this thing. So from the video, the only thing that I have changed are the profile types. Now they are actually they are currently the same. Is there are I-beams here and there, and then double beams putting side by side. But the only thing is that I changed the code. Now they are uh, following the British code. These are universal beams. Right, in the previous video I was using the Spanish codes, but no worries. So what do we have here? So the only loads that I have here applied is UDL 45 kilonewtons per meter here at the top of the truss. I know that those beams that I define here are too small for this load. So what I want to check if STAAD is gonna tell me, oh well, you know what, this beam is too small, or the section that you're using is not valid according to the Eurocode check, and which is the one that I should be using. So STAAD actually can tell you that. It can tell you automatically which beam you should be using here. So first what I'm gonna do is just to run this case, see what are the loads or the stresses that I'm obtaining here, moments, axial forces, shear, and then I'm gonna use my MATCAD spreadsheet to tell me um, uh, what are the utilization ratios of those elements here. In particular, to make the video a little bit shorter, I'm just gonna be checking this beam here, but that can be extended to anything you want here. So anything that I say here, you can apply to any other section. So I'm just gonna analyze this. Should be pretty quick. Done. I have 4 warnings there, and it's because I have in my code I have started to check the beams already. Um, it doesn't check if you have double beams. It doesn't do the check. So what it's telling me is that those beams that I have here, is 1, 2, 3, 4. Those are the 4 warnings that I'm obtaining. It's telling me I don't know if I can show you in this 3D version, but those are like double channel. It's like two channel sections creating one, but that doesn't really matter. So we're gonna focus on this. What are the stresses here? So currently with this arrangement, but if you want to see a little bit more, not this, the forces here. So I have big moments here and there. I'm not particularly worried about what happens down here. This is not really a stress, so that's why I'm gonna do the check for this beam only. So I go to the graph because, well, I could do it in many different ways, but for you to see the values and everything, I think this better. Okay, so what I have here in my MATCAD spreadsheet, it is a little bit blurry some things because as I use this for my work, I'm afraid that I cannot share this information with you. But anyway, I'm gonna, well, the thing that you can see is the things that you are able to see. So I'm just gonna modify this with the values that I'm getting from STAAD. This is the actual force. Currently I have applied 168 kilonewtons. A moment of, this is my maximum, 153 kilonewtons. Then ending moment of 65.4. The other ending moment 153. And shear force of 150 kilonewtons. I don't have any torsion, warping moments. Here, this material partial factor, this is important. I'm following the the British National Annex for the Eurocode. So those gamma M0 and gamma M1 are 1. Also, in the section properties, uh, these properties are wrong, but don't really pay attention to this. So I'm gonna highlight it somehow to know that this shouldn't be taken into account. Okay, so now I'm gonna define the properties of the section. How you do that in STAAD. So you go to here, section database, and I'm gonna check the so UB, then the 178, 102.19. I'm doing this a lot quicker than in the previous video because I assume that you have already watched the other video and you know what I'm doing. So that's the height of the beam, then the width, the thickness of the web is 4.8, but you can already tell that 4.8 millimeters is not a lot by the moment that I'm applying there. So this is gonna fail in so many places. So if I do this, I'm obtaining utilization ratios. In particular, the worst one is the combined shear bending and axial force of 57. So yeah, it is bad. It's pretty bad, as everyone could understand. So we're applying the 45 kilonewtons per meter in a section that is 100 millimeters height and 4 millimeters thick, or yes, and 8 millimeters thick on the flanges. Well, that's what you get. So let's see what stat tells me. So okay, so we're gonna start with the interesting thing of this video. I'm gonna go to here, still design. If you don't have this version of STAAD, I think this is the latest one, but if it doesn't change very much, but I think this menu is gray. That's the big change that they made from one version to another. So you go to still design. We have to define an envelope. So you should have already created an envelope. But if you haven't, then the only thing is just go to load envelopes, you add one, and just add the only load that we have defined, that is load case one. So that's the only thing that you have to do. So we create a new envelope. Already you could define here which envelope you want to use, and that's it. Then we have to define the members that we have to, or that we want to analyze. Here I have already created some members. What this creation of members do? This creation of members, what does is, here STAAD is understanding this as a beam, but what we want is to, for STAAD to understand it as a finite element model. So we need to right click and select form member. See that the little draw symbol that appears there is like from a beam to something with, I don't know, it's divided into three sections. It's like creating a finite element model from there. So that's it. That has created an M8, so member 8. Now if we go to restraints, it tells us information regarding the different elements. So well, the length and what are the ends, if they are fixed, if they are free, anything. Then we need to define the brief and the group. So what does this brief mean? Brief means uh, against which code are we going to do our check. So if you go here, you can select the American code, the old British standard, and well, others. It depends on your license of STAAD. So you have here more or less. So I'm gonna go the check. I'm gonna do the check with Eurocode 3. In this case, I'm gonna be working with this kind of steel with ultimate capacity of 430 megapascals. So here in this window, I'm going to explain a little bit what happens here. So you can do a standard Eurocode 3 check, or if you are working with a national annex in your country, you are going to need to modify a couple of things. So for instance, this gamma 0, I don't have 1.1 in the national annex, in the British national annex. So I need to change this to 1. Gamma 1 in the, I'm saying British, but the UK national annex is 1. Gamma 2 is 1.25, so that's good. And that doesn't really matter. There are some other parameters here. So if your ultimate tensile strength is different, or the yielding limit, if you want to define a different yielding limit of the steel, you can define it. If you leave it as, if you don't change this, then it will take the parameters by default of the Eurocode. So I'm just gonna change those two, the gamma 0 and the grade of steel, because this is important, and that's it. Then we have to define the groups. So here what I could do is I have defined those members. So I can define automatically to group. So I can tell STAAD, okay, I want you to do an analysis of all those beams that are running down here and assign them the same cross section, and the same for the beams at the top. So that's really useful because you can define your groups. So I want the, yeah, in a construction, a good construction way to do things is, so yes, definitely I will define all this to be the same cross section. This, then those vertical connectors, also the same cross section, like have to be different than these ones at the bottom. So, well, I could do that, but just to make things a little bit quicker, I'm just gonna add one group, and I'm gonna introduce in that group this member 8, that is this beam. If I would like to create another group for those ones, I will just need to add, or click group, add, and I will create another folder where I can put the design group 2 and I can put all those M1, 3, 5, and 7. But I'm not going to use that now, so I'm going to delete it and I'm going to leave just the M8. Okay, and now we go here to the result screen and I'm just going to go for member design, perform group design, and at first I'm just going to check the code. So if I check the code, good. So it's telling me actually this fails. Fails. That's good. That's good because that's what we wanted to obtain. So in particular, this thing here, I'm getting uh, in my MATCAD spreadsheet is failing by, well, the utilization ratio is 57, and here I'm getting 19. So STAAD is doing, actually, what is good of this is that it's telling me nothing here. It should tell me against which part of the code is checking this. So we go here back to there is problem here, beam, unity check, and now see it's telling me that the utilization ratio is 20.1 as we are obtaining from the still design. So what can you do now? Well, those as you see, all those are red, so those don't work. The ones are in green. It's like those sections are working for the loads that we're applying. So what you could do in if you don't automate this thing is just try. So you could go change the cross section, go to your calculation sheet or the MATCAD sheet, and do the check. See if it works. Doesn't work. Again, change the profile and do it again. So what you can do is to go here and say, I have gone back to the still design, member design, results, reports, and say member design, perform group design, and then member. Then STAAD tells me that my battery is running low. Good, good to know. Good. So it tells me, okay, if you use your original cross section, the 178 by 102, it was failing. So what STAAD tells me is that for the loads that I have applied there, what I will need is actually a universal beam 610 by 229. So it's way bigger than the one that I have currently. And that will make the combined axial and bending check to be at 0.9. So it really uh, it's under 1, so that's good, but it's pretty close. So well, it's really optimized. What you can do too is, or now you could change it manually, this, or you can let STAAD to change it for you. So if you go perform group design, member selection, multiple step design, if I want to do the design with the new section that the STAAD has told me that is needed, so I'll say 5 iterations. That would be probably more than enough to the check. And STAAD fails. Good. I'll come back in a second. Okay, so well, it has failed STAAD, but it shouldn't be. The only thing that has happened from before and now is STAAD had changed or has changed the beam. Now you can see we have a big beam there. And what are we gonna do now is to see if now with the new values for the cross section and well the load hasn't changed, but see it's the same. The only difference here is that the moments currently are slightly different, right? So what I have done is they are different because the structure is more rigid now. To modify I've modified already my MatCat spreadsheet, so now it shows, well, it should show those values. Well, uh, trust me. Good. And also I have changed the properties of the cross section to the 610 by 229, and the rest of the properties that was telling me that to do. So let's see with that new cross section, what we were obtaining, it was utilization ratio of 0.87. So if I do the check with my MatCat spreadsheet, what I obtain is a utilization ratio of 0.65. Well, so that's it. That's what I wanted you to show, and I hope you have learned how to do it. Now is your turn to decide of what you want to do. So up to you, but now you know how to do it. Well, I hope you like it. Bye.